Hello everyone and welcome to the internet. What we're going to be doing in today's lesson is having a look at the first group on the periodic table, the group 1 elements. So hopefully by the end of today's lesson you can explain those reactions of the alkali metals and recall a few key facts about them. To start us off, just a few questions to recap on our previous work. So those of you with target grades up to grade 5, it's the 4 questions on the left. Those of you with target grades over grade 5, it's the 3 questions on the right. So I'm just going to give you a couple of minutes to have a go at these today. Okay, let's check those answers then. So for the up to grade 5s, first of all, we've got 3 different elements and we can spot them by looking for new capital letters. For the number of atoms, there were 6. We have covalent bonds between nonmetals and they form by sharing a pair of electrons. So give yourself a score out of 4 for the up to grade 5. For those of you at grade 5 and up, it's still a covalent bond between nonmetals. They also form by sharing a pair of electrons. And then our dot and cross diagram for C2H6 should be like the one I've given you on the screen there. Now, I've given you the dots in a different colour to try to make them stand out. But carbon has 4 electrons in its outer shell, so there's 4 crosses for each carbon. Hydrogen, 1 electron in the outer shell. And then in order to give them that illusion of having that full outer shell, they share that pair of electrons. So you can see there's a dot and a cross shared between each hydrogen and carbon. And then we've got 2 crosses shared between the 2 carbons. So give yourself a mark out of 3 for the grade 5 and up. So what we're looking at today then are the group 1 elements. Now, the group 1 elements also have another name. They're the something metals. Hopefully we know what that missing word is. And there's a big hint on the left of the screen if you're not sure. And then I've given you the symbols. I want you to give me the names of all of those elements we find in group 1 on the periodic table. So get those points written in your books, filling in the blanks for me. I'll give you just about another minute and a half to get that done. Okay, let's double check to make sure we got all these right. Obviously, tick it if you did. If not, write in the correct answer so you do have the correct set of notes in your book. So group 1 are also called the alkali metals, and they are lithium, sodium, potassium, rubidium, cesium and francium. So give yourself a total out of 7 for all the bits you got right there. Now, if we were actually in school at the moment, this is the point that we'd get the alkali metals out, at least the ones we're allowed in school, and we'd actually get to play with them. And by play with them, I mean play in a very scientific and careful manner, of course. Now, the 3 we'd be looking at are lithium, sodium and potassium. And what we actually find is that these 3 alkali metals are actually very reactive with the oxygen we find in the air and with the water that we find in the air, or just general water. Now, they're stored in a very particular way, and I know that a lot of science teachers like playing with the alkali metals in their safe and scientific way when you lot are all in Key Stage 3. It's one of those experiments they just get out just because it's fun to do. Now, let's see if you can stretch your brain back if you have seen this before. Tell me how they're stored, why they're stored that way, and then if you can list any of the properties of the alkali metals. So write the first sentence, have a go answering those 3 questions. I'm going to give you a couple more minutes to have a go at that. Now, in terms of how we store the alkali metals, then they're actually stored in glass jars which are filled with paraffin oil. And the reason that we store them in oil, so they'll float around in there, is because it prevents them then reacting with the oxygen and the water that's present in the air. If we just put them in a jar with air, they'd react with the oxygen and the water in the air, and that wouldn't end well. So we store them in oil to prevent the reaction with the water and the oxygen in the air. In terms of the properties that we find of our alkali metals, then there's pretty much 4 key ones I suggest you remember here. First one is that they're shiny when freshly cut, as you might expect from a metal. They're good electrical conductors, again, they are metals after all. They're solid at room temperature, and one you may not have expected, they're actually soft enough to cut with a knife. And I've got a little demonstration in video form a little bit later on where you can actually see that you can cut it really quite easily with a scalpel. So if you didn't get those points written down, make sure you've got them jotted down in your books now. I'll leave these up for about another 30 seconds, but if you need longer, just hit pause. See if you can have a go at answering this question then. What do we think the trend in hardness of the metal is as you go down group 1? So just 30 seconds, jot that answer in your books. What we actually find is that as we go down the group, they get softer and easier to cut. So lithium, it takes a little bit of pressure to get through that one, but by the time we're down at potassium, it's just like cutting sort of cream cheese really. It just goes through so easily. So as we go down the group, they get softer and easier to cut. What I'd like you to do now then is just jot down this table in your book, because what we're going to do is watch a video of the demonstration we would normally get to play with in school, and you can just write down your observations as if it was live. Not as good, I know, and this is the best part of chemistry, is getting to blow stuff up, but sadly we can't blow things up through a computer, so we'll just have to watch the video of someone else having the fun today. But get this table in your books and then we'll watch the demonstration so you can fill in your observations for lithium, sodium and potassium. I'll just give you about a minute to get that table in your book.
Here I'm working with some lithium metal, very difficult to cut. I've got a piece of sodium here, pretty easy to cut. You notice when I cut through that the fresh sodium is very shiny compared to the rest. Let's zoom in real quick and see if we can really get in there. So this side will reflect a lot of light. The other sides are pretty dull. And you'll see that especially with the potassium here. I'm going to go ahead and give this kind of a half cut. So for the potassium, this is the side that's freshly cut, and you can see the dullness to the other sides compared to that one. So I'm going to go ahead and take those three, and I'm going to add them to water, and we can look at the kind of reactivity of those three alkali metals with water. So here I'm going to take the lithium, and add that to the water. It's going to generate hydrogen gas and lithium hydroxide. So you're going to see a pink color develop here, and then you're going to see some smoke come off, and that's either lithium metal or that's lithium hydroxide coming off of there. Maybe a little bit of liquid water. But it's not as reactive as, say, sodium, so I'm going to put sodium into the next one. And the sodium is actually probably going to ignite. So you'll see some orange flame perhaps, or some sparks, or some shrapnel. And then the last one, I'm going to go ahead and put my two pieces of potassium in. That I've cut in half. So this is less potassium than the other two in terms of amount. You'll find that the reactivity is a little bit greater. that potassium there was quite reactive there, but the sodium sometimes will allow hydrogen gas to build up. In this case, it's not igniting. We can try adding another piece here. We can hope that that's going to go ahead and actually send off some shrapnel and some flame. All three produce hydrogen gas, all three produce hydroxides. There's your alkali metals.
So hopefully in our tables we've started off with lithium basically just fizzing and moving slowly on the surface. It's the dull one. Then our sodium is going to actually catch fire as it touches the surface, but that's after, and this depends how carefully you looked at the video, it turns into a molten ball. So that means that as that metal hits the surface of the water, it becomes basically a liquid ball of metal that then zips around on the surface. As we saw in the second attempt at the sodium, it did catch fire, and then we actually burn with that orange flame. For our potassium, then as soon as it touches the water, that caught fire, and it burns with a lilac flame. Now the colour lilac is important that we remember that exact wording there. And it exploded as we saw it started popping and throwing little bits out. Now, what we need to understand is what's actually happening. One of the questions they could ask you is to actually write down what you'd expect to see or to predict what you would see in those. So you do need to know the observations we've just gone over. But they can also ask us about word and balance symbol equations. So we're going to kick it off with the word equations first of all. And what we've got at the top is the general word equation. So this is the one that applies to any alkali metal. It gives us the basic reaction. So instead of having the specific name, we've just got the word metal to represent the alkali metal. So metal plus water makes metal hydroxide and hydrogen. So what we need to do, if we then need to write a word equation for lithium, for example, we just change the word metal for lithium and everything else is the same. So it becomes lithium plus water makes lithium hydroxide plus hydrogen, because we always make the metal hydroxide and hydrogen gas. What I'd like to do is write down the top two and then have a go at writing the word equations for sodium and potassium for me. So I'll just give you about another 2 minutes to do that. Let's make sure we got those right then. Hopefully we've got sodium plus water makes sodium hydroxide plus hydrogen. tick it if you get that one right. And potassium plus water makes potassium hydroxide and hydrogen. Tick that one if you got it right. What I want you to do now then is just 30 seconds to jot down the pattern that you noticed in the reactions of lithium, sodium and potassium reacting with water. Hopefully what we've written down is that as we go down group 1, they get more reactive. Think about it, when we've got lithium, which is near the top of group 1 there, then what we actually find is it just fizzed slowly. But by the time we've moved further down to our potassium, it catches fire, it explodes, it's way more exciting and therefore way more reactive. So the further down group 1 we go, the more reactive they get. See if you can have a go at answering the question at the top. How many electrons do the group 1 elements have in their outer shell? So literally just going to give you 30 seconds to write that answer down. Hopefully we did remember that group 1 will all have 1 electron in their outer shell. Because remember, it's kind of like the little cheats guide to how we know how many electrons are in the outer shell. You look at the group number. Group 1, 1 electron. Group 2, 2 electrons. Group 6, 6 electrons, and so forth. Now, the fact that they've all got 1 electron in their outer shell in group 1 tells us that they're all going to have similar chemical properties, because the way in which they react is going to be very similar. Make sure you've got those 2 sentences written in your book if you didn't already. Now, what we've said is that they've all got 1 electron in their outer shell in group 1, so they're all going to react in this similar way. The reason that that happens is that that 1 electron is going to be lost from the outer shell to make a positive ion, and that positive ion is going to have a single positive charge. So when we form a sodium ion, it's going to be Na+, potassium ion, K+, and so forth. Make sure you've got those 2 sentences written in your books. So word equations are the easier of the ones to deal with. Now we need to look at the balanced symbol equations. So at the top I've given you the general balanced symbol equation for the alkali metals reacting with water. So the capital M represents our metal, H2O is water, our OH after the M on the right hand side, that's our metal hydroxide, and H2 is hydrogen. Now I've also given you the state symbols there, so our metal is a solid, hence the S in brackets, water is a liquid, L in brackets, our sodium hydroxide or metal hydroxide is going to be an aqueous solution, AQ in brackets, and hydrogen will be a gas, hence the G in brackets. Now what we need to go careful of here is the way people throw away the marks on this is that they fail to write the formulas and therefore they fail to balance it. Because they forget that hydrogen goes around as H2. If you don't remember that little subscript 2 after the hydrogen, it's not going to be the right formula, it's not going to balance then. So that means you've thrown away both marks on a balanced symbol equation question. So hydrogen, always H2. And you'll also notice one great little thing about this. If you hate balancing equations and just think, I can never do them, you can just learn this little rule. That a 2 goes in front of everything except for the hydrogen gas. Whenever we've got our alkali metals reacting with water, it will always be the same thing. 2 of our metal plus 2 water molecules makes 2 metal hydroxide and 1 hydrogen gas molecule. So write down the general balanced symbol equation at the top, then have a go at writing the balanced symbol equations for lithium, sodium and potassium. Once you've done that, see if you can write down how we could test the gas to prove it's actually hydrogen. So I'm going to give you about another 3 minutes to do that. Let's just quickly check to make sure we got all those balanced symbol equations right. So 2Li plus 2H2O makes 2LiOH plus H2. Tick it if you got it right. 2Na plus 2H2O makes 2NaOH plus H2. Tick that one. And then 2K plus 2H2O makes 2KOH plus H2. Now, in reality, each one of those could be worth 2 marks. They're not going to give you 3 of them on the exam paper. They're going to ask you to write 1 of them. But make sure you know how to do this, because not only could it be a standalone 2-mark question, it could also come up as part of a 6-mark question, and that would be the difference between one of your levels of answer. In terms of how we test for hydrogen gas, a lit splint makes a squeaky pop sound. So any of those you didn't get right, then make sure you write them down now. I'm going to leave this up for about another 20 seconds, but if you need longer, hit pause so you've got a chance to get these written in your books. Now, earlier on, we talked about the fact that our alkali metals are all going to lose that outer shell electron to form a single positive ion. Now, the reason that we've got this trend in reactivity, that as we go down the group, they get more reactive, it's all linked into how easy it is to lose the electron from the outer shell. And what we find is that the easier it is to lose that outer shell electron, then the more reactive it will be. So write down that top sentence for me and then see if you can answer the question at the bottom. One of the things that you really should get used to seeing is that phrase oil rig. Now, oil rig is just a cheating way of helping us to remember what happens in two types of reaction. So oxidation is the loss of electrons, reduction is the gain of electrons. So oil rig just stands for those parts there. What we're going to be looking at today is oxidation. We're looking at the loss of electrons. Because if we think back to what we've said, the metal is going to lose one electron from its outer shell to form a positive metal ion. So it is being oxidized because it is losing electrons. We can write the ionic equation then, and again I've given you the general ionic equation in the middle. M standing for our metal, and E- is our symbol for the electron. So we start with our metal atom, and then we're going to form the metal ion, which is going to have a single positive charge, hence the little plus to the top right, and an electron, E-. Write down the top couple of bits and then see if you can write the ionic equations for lithium, sodium and potassium for me. Let's make sure we got those right then. So lithium is Li, makes Li plus E minus. Sodium is Na, makes Na plus E minus. And potassium is K, makes K plus E minus. So give yourself a mark out of 3 for those. The last things we need to know about the patterns that we find, or the trends, are that as we go down group 1, their densities will increase and their melting points will decrease. So just jot those 2 down and make sure you learn those other 2 trends. Final thing for today then, plenary questions up to grade 5, it's the column on the left. Grade 5s and up, it's the column on the right for you. So if you need longer, then pause the video. I'm only going to leave this up for a couple of minutes today.